In this video, let us solve example 3 from the chapter Statistics. The question is, the distribution table below shows the number of wickets taken by bowlers in one-day cricket matches. Find the mean number of wickets by choosing a suitable method. What does the mean signify? Table is given here. Here number of wickets and number of bowlers are given. This is the question. Now let us change this table like this. In the first column, let us write class interval, which contains 20 to 60 means number of wickets taken by the bowlers. 60 to 100, number of bowlers is 5, that is FI is 5 here. 100 to 150, number of bowlers is 16. 150 to 250, number of bowlers is 12. 250 to 350, number of bowlers is 2. 350 to 450, number of bowlers is 3. We are asked here to solve it by suitable method. Before, we have to take xi, that is class mark. Anyhow, isn't it? For all the three methods, we have to take the class mark, that is midpoint here. Now let us add one column for xi. How can we take xi? Class mark, lower class limit plus upper class limit. How much it is? 80. 80 by 2 is 40. Here lower class limit is 60. Here observe class size is different for different class intervals. So now we cannot go on adding the class size to get the next class mark. We have to count it in each and every case. 60 plus 100, what it is? 160. 160 by 2 is 80. 100 plus 150, what it is? 250. 250 divided by 2, what it is? 125. 150 plus 250, what it is? 400. 400 divided by 2, 200. 250 plus 350, 600. 600 by 2 is 300. 350 plus 450, 800. 800 by 2 is 400. Now let us see which are the methods we can use. One is direct method, the formula for which mean is equal to summation of fi xi upon summation of fi. Assumed mean method, the formula for which is a plus summation of fi di upon summation of fi. The step deviation method, the formula for which is a plus summation of fi uy by summation of fi into h. We can use step deviation method more properly because both fi and xi are of the higher numbers here. For step deviation method, we have to assume a mean a, and also we have to find ui, and also we have to have the class size. Let us come to the class size. What is the class size here? Here the class size is 40. Here the class size is, this is also 40, okay. Here the class size is 50. So it is varying, observe. Here also the class size is 100. Here the class size is 100. Here the class size is 100. For some of the class interval it is 40. So for some it is 50, for some it is 100. So let us use step deviation method only, but the class size we have to think over it, which is the class size. So now we are using step deviation method to find the mean here. We have to assume a mean now among xi, the numbers of xi. Here we are needed to find ui. Ui is nothing but x minus a by h. So we have to determine h also here. Since we cannot determine h easily since class size is varying. So here we have task, isn't it? To find the assumed mean. Here the two highest frequencies are 16 and 12. Any number among xi we can have for assumed mean, but let us use some sense, and the problem should be very easy to solve. If it is very clumsy, once again it is of no use, isn't it? Okay, if it is 125 assumed mean, observe x minus a, that is di, isn't it? Di. 40 minus 120, what it is? Minus 85. 80 minus 125, what it is? Minus 45. Here no common factor other than 5, isn't it? 5 is too small. What is the use of having a bigger number di, isn't it? So now let us discard at the early stage only. Okay. Let us take 200 as assumed mean. Here let us count the numbers. 40 minus 200, what it is? Minus 160, isn't it? 80 minus 200, what it is? 40. We can have 20 as common factor here for both cases. Let us compute more. Let us calculate more DIs and then let us write in the next column. 125 minus 200 minus 75. 200 minus 200, it is 0. 300 minus 200, it is 100. 20 can be a common factor. Here also 400 minus 200, it is 200. So now we can have 200 as assumed mean. So now we have a column for di. So now let us write here 160, here for minus 40, minus 75, 0, 100, 200. Here observe that we can have 20 as a common factor, isn't it? Why? 50 is divisible by 20, 120 is also divisible by 20. Only this number means 75 has some fractions, but it is okay to have it, and other numbers also divisible by 20. So now let us take h as 20. Now we can calculate ui because we can observe that the common factor is 20 here. So now let us create a column for ui, which is equal to di by h is equal to 20. Minus 160 by 20, what it is? Minus 8. 0, 0 get cancels, minus 8. Minus 120 by 20, what it is? Minus 6. Minus 75 by 20, what it is? 7.5 by 2, negative of 2 3s are 2 7s are 5s are. This is 0. 100 by 20, it is 5. 200 by 20, it is 10. So now let us have a column for fi ui. Means we have to multiply the numbers in this column and also in this column. 7 into minus 8, that is minus 56. 5 into minus 6, that is minus 30. 16 into minus 3.75, what it is? 16 5s are 80, carry 8. 16 7s are 112. 112 plus 8 is 120, carry 12. 16 3s are 48. 48 plus 12 is 60. 12 zeros are 0. 2 5s are 10. 3 10s are 30. Now let us find the summation of fi. What it is? 7 plus 5, 12, 12 plus 6, 18, 18 plus 2, 20, 25. Carry 2, 2 plus 1, 3, 3 plus 1, 4. Now let us find summation of Fi Uy. Here you can observe that positive of 30 and negative of 30 can get cancels. Here the total is minus 116. Here positive of 10. So now you can add negative of 116 and positive of 10. What it is? Negative of 106. So summation of FIUY is 106. Now we are finding the mean by step deviation method, the formula for which is A plus summation of FIUY upon summation of Fi into H. Here A is 200, summation of Fi is 45, summation of FIUY is minus 106, H is 20. So now let us substitute the values. So mean is equal to A is 200 plus summation of FIUY is minus 106, summation of Fi is 45 into H is 20. 200, here 5 4s are 20, 5 9s are 45. 4 into 106. What is it? 424. 424 upon 9. That is equal to 200 minus what it is? 47.11. 200 minus 47.11. 152.89. This tells us that on an average, the number of wickets taken by these 45 bowlers in one day cricket is 152.89.